So let's do the related rates ones for related rates one first. So I guess it's going to take a second. I'm just going to go through the steps on the solutions I gave you. So this is a problem. I used to do this one on a test, and I failed years ago on this problem because it's not a great problem. But I had a drawing all built, so I used this one. You have to really read these things carefully. And the ones on the test, so the format is I'm going to give you 3 problems to choose from, 3 related rates problems to choose from, and you only have to do 2. So you can try them all and pick which 2 you want me to grade. I've added a bonus one also. I'm not sure how I'm going to deal with the bonus one, but if you have time, do it, and it'll be something good. I'm not sure if it'll replace a problem, or maybe I'll let you get some points back on one that you otherwise miss, or something like that. But it's worth your time to do if you have time. On the related rates part, the paper and pencil part. So on this one, if we read through this, it says a fish is reeled in along the surface of the water. So in other words, the fish is being dragged along the surface of the water is what that implies, right? It's not like that he's down below the water somewhere. That makes this a really difficult problem. But he's just being dragged along the surface. He's real tired, I guess, from fighting. At a rate of 2 feet per second from a point 15 feet above the water. Okay, so that's a little ambiguous, and I agree with you. What that's saying is that this guy up here is reeling in line at a rate of 2 feet per second, and the fish is moving along the top of the water. Okay, because you could interpret that in different ways defensively, I think. I mean, I can see how you could see this a little differently. And in fact, I think when I gave this problem, I actually graded it both ways and gave people credit if they did it the way, but I think you did it that way, Kirk. I think I would have given them full credit on that way too. I didn't write that solution up though. So we want to know at what rate is the angle between the line and the water, so there it is, theta, changing when there's a total of 25 feet of line from the end of the rod to the water. Okay, so the variables are already defined for us, right? So everybody agree our snapshot values of the variables are these, right? We know that at the frame in the movie we're looking at, x is 25, x dot is -2 meters per second, right? And we're looking for theta dot, okay? And if you leave the units off, oh, you know what, that's not supposed to be meters per second, is it? Whoop, that's supposed to be feet per second. Feet per second, you might make that change on your solutions. Okay, and that's what we got. Okay, so we need a parent equation then, right? What's the parent equation? There's several that we could use, and so I do want to talk about this for a second. There's several that we could use. We could use, because we've got a right triangle situation, correct? So we could use tangent. Do we want to use tangent?
No.
We certainly don't want to use tangent. How come?
That's another variable.
There's another variable there that we don't know anything about, and we'd have to calculate another snapshot variable. And why introduce that idea? Why introduce another variable that we don't need? We're trying to reduce the number of variables down as much as we can every time, right? So certainly we don't want to do that. So then this sort of guides us to using the sides 15 and the hypotenuse, right? So we really have the options. We could either use sine theta would be opposite over hypotenuse, so that would be 15 over x. Or we could use, I guess, cosecant, right? Cosecant theta equals x over 15. Take your pick, really. I guess, personally, I would use sine. I know it makes the right side a little bit easier if we use cosecant, but think about the two derivatives. The derivative of sine is just a single ratio, right? Cosine. Derivative of cosecant would be negative cosecant cotangent. Just a lot more going on there, right? So to me, we're going to bail on that one, right? And we're going to use the parent function instead. If you didn't get one, I put it on your desk. Never mind. Yeah. Okay. So if we there's our parent function, right? Okay. So now what? You take the derivative, yeah. Differentiate implicitly with respect to t. And what are we gonna get? So technically on the right side, how would we probably wanna rewrite that, at least in our head?
15 times x sine.
Okay, good. And there's a point I wanna just remind you about there is, we don't use quotient rule when we have a constant on the top or the bottom, right? If it's a constant on the bottom, we just pull it out front as a fractional coefficient, right? If there's a constant on the top, quotient rule works, but it's way overkill, right? All we've got to do there is just bring whatever's on the bottom up to a negative power. So we use the generalized power rule instead. So we would just rewrite this as 15x to the minus 1. Much, much easier to deal with. Then we have just a simple chain rule problem rather than a quotient rule problem, right? So when we differentiate, we're going to get the derivative of sine is cosine theta, and then we got to go theta dot, right? Because we're differentiating with respect to t. On the other side, we're going to get our negative 15x to the negative 2, but let's go ahead and just put that at x to the negative 2, put the x on the bottom as an x squared, times x dot, because it's a chain rule deal. We're differentiating with respect to t. Okay. And then next step, I guess, would be, and I don't know if it's step 3 or step 4, but it's somewhere in the middle. We're just trying to isolate theta dot, so we can do that pretty easily. We can just divide each side by cosine theta, right? Dividing by cosine is the same as multiplying by secant, because cosine is the reciprocal of, or secant is the reciprocal of cosine. So 1 over cosine equals secant. So we'd want to write it this way, wouldn't we? Right? Okay? Well, when we plug and chug, we're pretty good. We've got our x that we can plug in there. We've got our x dot that we can plug in there. But what about this? What about the secant theta?
That we solve the triangle where we get, we can solve it.
Yeah, we can do that, right? We can make a little reference triangle and add that wherever you want it. Really, technically, I think it's a good place to put it is in step 1, the snapshot values, right? Because these are the values at that one instant in time. We remember that we're 25 feet of line is out. That's a constant 15, and so by Pythagorean theorem, that's 20, right? It's just a 3, 4, 5 triangle. So we can fill that in, and that, to me, that's the way to do it. Then we know that secant is just going to be the ratio of what over what? Right, so it can be a reciprocal of cosine. Cosine of theta would be 20 over 25, so this is 25 over 20. Right? You do have the option, if you want to, you could go up here and you could say, based on this relationship right here, if we solve that for theta, theta would just equal the arc sine of 15 over 25, right? And add that value, that's just a number. So we could add that to our snapshot values if you want to, right? And then just plug that in directly into secant if you wanted, right? But I prefer to use the snapshot values. Okay. So that's what we get, isn't it? Secant is 25 over 20, we can reduce it to 5 over 4, and so if you just plug and chug all that stuff, when all the dust settles, you end up getting positive 3 over 50. And the units would be radians per second, right? If you're wondering why, I mean, why not degrees? Well, how would the math gods know about degrees, right? I mean, they didn't make degrees, we did, right? It's 360, but arbitrarily, if somebody decided, well, we're gonna make it 3,600, that shouldn't change the answer to a math problem. If somebody in Spain decides we're gonna unilaterally change the number of degrees in a circle, how would that, obviously that's wrong. That can't instantly impact every math problem that's ever been done, where there's no mention of what units we're using. It's gotta be radians, because that can't change. That's always 2 pi. Okay? So, there's the related rates problem, and you just give me thumbs up or thumbs down on these. I would say, these, you've done all these, but if there's any of them you want you wanna go through, I just picked sample problems. Yep.
It's just for the assignment, but it's not like you can go back to school.
What?
Because you must have access to this assignment from a certain, for a specific ID hours.
On the practice test? Here, I'll fix it. I don't know why it's doing that. The practice test for the implicit differentiation. Okay, settings for class. Oh, yeah. All right, try. You might have to like back out of that and try again. Now it should be good.
Yeah.
It worked. Okay. Okay, so you tell me. I mean, I'm assuming that one probably you're fine with, right? It's not a big deal. You just, I mean, this is, we went through a bunch of these. You're just differentiating implicitly. You're going to get some terms with y primes, some terms without y primes. Collect the y prime terms on one side, other terms on the other side, factor a y prime, and divide by the remainder, right? Whatever's left over. That's a fancy water bottle you got there.
Yeah, where's mine?
Oh, you noticed.
I
There we go.
realized after I put it on the ground. Wait, you
No, we'll do it later.
didn't do that.
Okay. Thumbs up, thumbs down. No takers.
No.
Okay. I'll keep going. Thumbs up, thumbs down.
We know the answer.
Well, I know, but I don't care about the answer. There's the answer. You know how to do it is my question. You want to go through any of that? Yay, nay? Okay, we good? Tangent line. Good?
Oh wait, I like to do two
Want to do a tangent line one?
Yeah.
Okay, I'm doing this one. If you don't want to watch this, that's fine. You can just keep working away, and I'll tell you when we're done, and I'll go to another one. Yeah. There you go. You betcha.
Huh?
Okay, so if we want to, all we're really going to do here, remember, is we're just going to, ultimately, we've just got to plug in values for that stuff and simplify it, right? That's equation number one. We know there's my point x1, y1, so that's a 0 and that's a 1, but we got to find m. So we find that by differentiating. If I differentiate implicitly, I'm going to get y prime equals 7 times, what about the derivative of sine of hand, right? So the derivative of sine hand is cosine hand times the derivative of hand, which is going to be pi minus y prime, right? And so I've just got, now it's just algebra. Now I've got to solve for y prime and evaluate the derivative at that point. So this is one where, wouldn't it just make more sense, being as all I really want is the slope of a tangent line, why not just plug in the values first and then solve for y prime, right? I mean, you can do it either way, but doesn't that make sense? We don't really need to know what y prime is in terms of the function. We just need a specific value, the derivative, right there, right? So let's just plug and chug first. If I plug these values in, I get y prime equals 7 times the cosine of negative pi, right, minus 0, times pi minus y prime. Well, what's the cosine of negative pi? That's right there, isn't it? What's the cosine is x or y? So negative 1. Okay, so we just end up with y prime equals 7 times -1 is just -7 times pi minus y prime. This is looking pretty easy now. If I distribute the -7, so what's that going to give us? When all the dust settles, if I subtract that y prime to this side and add 7 pi, 6y prime equals 7 pi, so y prime equals 6 pi. Right? And that's the slope of the tangent line. So if we go back up to this step up here, and we plug everything in, we just get y minus 0 equals 6 pi times x minus -1, so x plus 1. I just distribute and I'm done. Let's make sure we got it right. We did. There it is. Okay.
Go put this on the line
Yep. Yep. I'll do it for sure. I'll do it like right. If there's time at the end of the period, I'll do it right now. Otherwise, I'll do it right after school for that basketball. So it'll be up there. And all the notes will be up there too. Okay, yay or nay? I'd say skip that one, because if we need to do a second derivative one, I've got a harder one after this we can do instead.
That's the answer.
What's that?
That's the answer.
The answer? Yeah. There's the answer. Yeah. Logarithmic differentiation. I picked the kind of the hardest one possible to know. Yeah, good one. I think that, to me, that would be a reasonable one to do.
Oh, it's good.
So we're going to log both sides, right? And you can see, I mean, they tell you to do logarithmic differentiation, but even if they didn't, that's obviously one you want to use it on, because look, we've got products and quotients, and inside those we've got powers, right? So that's an ideal candidate for logarithmic differentiation. It makes this one so much easier. So the natural log of y equals the natural log of that whole thing. And then by properties of logs, what are we going to get on the right side when I apply all my properties? So I'm going to get, what's that going to give me? Just log x plus the log of that, but what can I do to that to simplify it? Square root is the same as what power? Okay, so I got 1/2 log of x squared plus 2, right? And then minus, everybody agree, 7/3 natural log x plus 4? That's just log y. Way easier. Now I can differentiate both sides implicitly with respect to x. So what do I get on the left side if I differentiate log y with respect to x? Derivative of log u is just u prime over u, right? So derivative of log y is y prime over y equals derivative of the first term, derivative of the second term. I'm going to get, there's my u, right? So I'm going to get u prime, 2x, over u, but I've got this 1/2, so I'm gonna put the 2 on the bottom. Okay. And then x squared plus 2. Okay. I could cancel those, right? They're factors. 2 is a factor of the bottom, and 2 is a factor of the top, so I can cancel them. Minus 7/3. But what else goes on top? What's the derivative of log? Well, u prime is what in this case? 1. There's u. Okay, so that's my answer. Then all I've got to do is just multiply both sides by y. And so my final answer would just look like y prime equals, if I multiply each side by y, I'm just going to get y out in front. What is y? Well, there it is, right there. Right? So it's x times square root of x squared plus 2 over x plus 4 to the 7/3. So there's my y on that side times all of this stuff, right? All of this stuff right here. My 1 over x plus x over x squared plus 2 minus 7 over 3 times x plus 4. That's how I do it. You don't need going through it. Okay. And did I put answers on that? No. Let's just make sure. Okay, make sense? Right. If you want to do a second derivative one, that would be probably the one to do, and that's the other one. Or that one, I don't care. If you want to do any of them. Exhibit A, Exhibit B, or I can do both. That one?
Sure.
Doesn't matter. Okay, that one? All right, so if I'm going to take a second derivative, I'm going to differentiate implicitly and get 5 plus 3y prime equals 2. What's the derivative of sine y with respect to x? Cosine y times y prime, right? Derivative of sine hand is cosine hand. Derivative of hand is y prime. Okay? And so if we solve for y prime, what would I get? So I'm going to have to push this term to the other side, subtract the 5, so I'd end up with 2 cosine y minus 5 would be the non-y prime terms. We get pushed to the right, agreed? Divided by what I get on the left when I factor out a y prime. Well, that's going to be a 3 minus, because that term got subtracted to the right, or the left, sorry. 2 cosine y. Or we could multiply those by -1 if we want. Doesn't matter. So there's y prime. They want to know the second derivative though, right? So let's go, we don't want to use quotient rule. So instead, we'll just go back to this step and differentiate again. So if we differentiate again, that's going to go away. Derivative of 5 is 0. That's going to give me a 3y double prime. On this side, let's just wrap the 2 with the cosine y. Like that. Okay. And so we're going to get a product rule, aren't we? That's like my u, and that's like my v, and I've got a product rule. So I'm going to have u, which is 2 cosine y, times dv, which is y double prime, plus v, which is y prime, times the derivative of u, which is gonna be negative 2 sine y times y prime, right? And now I would just have to collect the y double prime terms on one side, collect the other terms on the other side, and eventually plug in y prime. So we would subtract this term over that way. 3 y double prime minus 2 cosine y double prime equals here I'm going to, I could distribute this through and get negative 2 sine y times y prime times y prime is just y prime squared. So that's equal to, well, I'm going to leave it like that for a second, actually. I factor out a y double prime, leaving me with 3 minus 2 cosine y is all this stuff, negative 2 sine y times y prime squared. Then I'm just going to divide everything through by 3 minus 2 cosine y. Right? Multiplying by y prime squared, though, well, there's y prime. Right? So let's just erase this. And replace it with that quantity squared. So we're really just multiplying by, when I multiply this whole thing by y prime squared, I'm just multiplying by 2 cosine y minus 5 squared over 3 minus 2 cosine y squared. And look what I get here. 3 minus 2 cosine y times 3 minus 2 cosine y squared is what on the bottom? There you go. Right. So my final answer just looks like negative 2 sine y. Don't do anything, just leave it. I know it's a mess, but just leave it this way. Who cares? 2 cosine y minus 5 squared on the top, and on the bottom I just get the quantity 3 minus 2 cosine y cubed. There it is. Their answer, looks like they, oops, they did one thing slightly differently, which is fine. They're equivalent answers, I think. Let's look more closely. What they do. That looks a little different. Where's the 50 sine y?
I know. Well, 5 squared is 25. Yeah.
Yeah. Did I calculate? Oh, did I do- that's supposed to just be a 5 on top, isn't it? Oh, yeah, look up. How did I get this? Y prime is, yeah, this is just a 5, right? That's just a 5. This is all one term. These are being multiplied, right? So this is incorrect. Let's change this. Right, I'm just gonna erase this and we'll change it at the bottom too, right? So what if I'm solving for y prime? We could either put the y primes on this side. Let's put them on this side, being as we've only got one term on this side and 2 on this side, right? So the steps we'll take, here, we'll fix this, this is no big deal. So we're gonna end up with 5 on the right. On the left side, we're gonna get 2 cosine y times y prime minus 3 y prime, right, over that's it. Everybody agree? I'm just subtracting this over to this side, okay? Let's factor out a y prime. Right? And then just divide each side by this. Right? And so we end up with y prime equals 5 divided by that. There it is, right? And so,
Redo up in 2 seconds.
let me kind of separate all this stuff off here. So this stuff, right, that's just all work to figure out what y prime is. And then here we just powered on through and differentiated implicitly again, okay? Okay. That changes, it just changes, so the only difference is let's rewrite this down here. When I square that out, I'm gonna get, top squared is 25, on the bottom, I get 2 cosine y minus 3 squared, right? And then over here, that looks different, but what if I just factored out a negative 1? If I factor out a negative 1, I get that, right? Which is 2 cosine y minus 3. So then on the bottom, there's our, on the bottom, there's our 2 cosine y minus 3 cubed. What else are we left with then? We're left with negative 2, but negative over negative, those cancel, right? So I get positive 2 sine y times 25 is just positive 50 sine y, right? Do the same thing. That's,
So was the other one wrong?
which one?
The one that we answered that for?
Yeah,
Oh.
yeah. And you see why? Because I had the wrong derivative. Right, when I plugged in for y prime. I don't know what I did. I did something real dumb. Somehow I had 2 terms on the top instead of 1. I did, I must have, I don't know what I did. I'm not sure. I don't know. Brain fart though, whatever it was. Okay. There it is. I'll put, like I said, I'll put these up in the notes right away. Do you want me to go through? I can do another one if you want to do that one too. I'll do it. You can either tune me out and work on stuff, which is fine, or you can watch if you want. So we're trying to find, I'm just gonna find, well, I guess we have to find the first one anyway, in order to find the second derivative. So first step, 2y. This, by the way, this is a much harder problem than anything on the test. I just picked one that I thought was same kind of problem, but an especially hard one for the review. So 2y prime equals derivative of e to the u, remember, is e to the u, u prime. So we're going to get 5 e to the x squared times the derivative of x squared, which is 2x. So why not just instead make that a 10x out front? Plus 12. Right, so if I solve for y prime, I'm just gonna get y prime, I could divide everything by 2, couldn't I? Make that a 5, that a 6. So I'm gonna get y prime equals all this stuff just divided by y. So 5x e to the x squared plus 6 divided by my y. So there's y prime. Now we'll keep going and do the second derivative. I'll rewrite this line. So if we go one more step with that, I have to use product rule here, don't I? So I'm going to get first, which is y, times the derivative of the second, which is y double prime, plus second times the derivative of the first, which is y prime, right? So it's the same thing as a y prime squared, equals, what about here? So I've got another product rule, don't I? Let's just group the 5 with the x. So I'm going to get 5x times the derivative of e to the x squared. Okay, that's going to be 2x e to the x squared, right? E to the u du. Okay, plus e to the x squared times the derivative of 5x, which is 5, and then the derivative of 6 is 0, right? So one nice thing is there's only one y double prime that I have to isolate. That makes that part easier. So we get y double prime. Let's subtract that to the other side. Equals, I can make that a 10x squared e to the x squared plus 5 e to the x squared, and we're subtracting that y double prime squared, or y prime squared, sorry, subtracting the y prime squared to that side. Let's go ahead and just replace the y prime with what it is. And so that becomes if I square that out, what am I going to get? So on the top, I'm going to get the quantity 5x e to the x squared plus 6 squared. On the bottom, I'm just going to get a y squared, right? So I'm going to divide both sides by y, but another way, rather than divide by y, let's just distribute through a 1 over y. So I've got my y double prime equals this whole thing times 1 over y, right? So if I distribute that through, I'm just going to get 10x squared e to the x squared over y plus 5 e to the x squared over y. And you could combine those and factor things out if you want to, but you don't have to. That's fine. Minus 1 over y times this is just going to give me a y cubed on the bottom. There it is. Okay, that's fine. I don't know if that's exactly what they put for their answer. It looks like they got a common denominator, and in these two terms, they factored out a 5 e to the x squared. You don't have to do that stuff. That's fine.
like all the way, no.
Right there?
Yeah.
Okay.
And scroll down all the way to the bottom.
Okay, so there's that. How's that right there?
That'd be great.
Now you got everything.
Thank
Okay.
you. No.
Okay, I'm gonna upload it right now though, so it'll be on the site, on Moodle.